Good morning, early birds. My name is Adrian Choy. I am with Omron. I am Omron's robotic product manager for the Americas. And today I will be talking about myth busting robotic safety. There's been a lot of misconceptions with AMRs and collaborative robots. I think we've all been to a trade show where companies are being a bit cavalier with their robots because they have engineering supervising demos, or they want to show off the capabilities in a non-typical environment. But that has also led to people thinking that these types of robots are safe out of the box. Before I go too deep into this, I wanted to introduce Amran. So we have existed for almost 100 years at this point. We were founded in Japan, focused on components, but since then we've developed PLCs, HMIs, safety gates, motion drives, and of course, robots. So we are a full automation provider with a global footprint. Brief primer on cobots and AMRs. To delineate things, I will be referring to both as collaborative robots, which they are technically, but the industry has basically reserved that terminology for just the six-axis arms we're familiar with. So when I'm speaking about the arms, I'll be referring to those as cobots. When I'm speaking about both, I'll refer to those as collaborative robots. So in a nutshell, these are industrial robots designed to share workspaces and or interact with people. That helps simplify things in terms of making the real estate more manageable. So you can have humans sharing workspaces with the robots instead of having uh, extensive safeguarding. And some of the features that enable this are fast integration, flexibility, simple programming. There's usually feature sets that make integrating these robots into an existing environment fairly streamlined, be that simplified programming languages or ease of use features like being able to scan a map with an AMR by simply having a joystick and driving it around. Additionally, there are many partners of ours that have plug and play accessory ecosystems. So companies like Shunk and Roec have off the shelf gripper or topper solutions for these robots, which further simplifies developing a robotic solution. There's also options to limit speed, power, or force limiting in certain scenarios to help comply with safety standards and regulations, and sensor skirts to actually enable that to sense the environment around it. Now, these robots are capable of being installed with limited safeguarding, and we're going to put a pin in that. So most people's understanding on collaborative robots are cobots are safe out of the box, AMRs are safe out of the box. And if you put a cobot on top of an AMR, you get double the safety. I think we can all agree that that's not necessarily the case, but that has been public perception thanks to us talking about safety in terms of marketing, but not really getting into the nitty gritty on what you need to do to actually achieve that. Hopefully, by the end of this talk, we can understand how to communicate safety to customers and end users, and even develop our own understanding, and also appreciate how safety can actually boost our efficiency. So we're going to do some myth busting today. And I have three misconceptions I want to correct. First one, collaborative robots are inherently safe out of the box. This is a huge misconception I find among people, especially end users and customers new to robotics. An example here is a university in Shenzhen during lockdown used a certain competitor's cobots to do COVID samples, nasal and oral. There are specific standards that say that your cobot is not allowed to come into contact with someone's head or neck. So this is automatically a no-go application. Interesting idea, but not the intended scenario for collaborative robots. So what's the reality? Collaborative robots are designed to adhere to standards and regulations. You'll often see in marketing material, this cobot adheres to ISO TS 15066, or this AMR complies with ANSI B56.5. Now, that means that these products are capable of complying with that, but you still need to put in the sweat equity to make sure that the way you apply that robot complies with those standards, because an application must also be collaborative. One of our engineers at Omron has a line that I'm going to steal. You can't put an ice pick on a cobot and call that a collaborative application. We've seen people put hot tempered glass on top of AMRs and have them driving around in spaces with people. Obviously, you don't want anyone to come into contact with 300-degree glass. You don't want to have a cobot waving a knife around with no safeguarding around it. You have to have the right application if you actually want this to be considered collaborative. It doesn't solve all your problems just inherently with the robot. So when you're looking at whether or not your application is collaborative, you have to take into account all the variables. Your payload, what are you carrying? Once again, if you're carrying molten glass and you're driving that around people, that's not a collaborative application. The shared workspace, if the robot's in motion, are you going to create entrapment scenarios where you block exits or prevent people from moving back and forth in an emergency? Even the tooling, once again, blades, anything that has too much motion like a conveyor topper, when those are in motion on an AMR, you have to be considerate on how and where that's used. Even the payload. So we'll get into a deeper dive on this. But for palletizing applications, if you have a cobot running full speed, that 10-kilogram payload can turn into a 10-kilogram projectile if that gripper fails. So I listed here some common cobot standards and regulations for both the cobots and the AMRs, but this technology is pretty nascent. We're trying to catch up with where the technology was and when the standards were written to the present day. The standards and regulations are always evolving, especially for AMRs. We're actually going to see some standards come out and take effect in 2027 from Europe. So don't always think that if you were in compliance once that you're always going to be in compliance, and expect that from robot manufacturers as well. Second misconception. So with all that hullabaloo about they're not safe out of the box, you still need to do your due diligence, then what's the point of using a collaborative robot in the first place? You're telling me that I still have to put in safeguarding and pay for all these safety products. Well, why the hell am I not just using a traditional robot like you see with these 6-axes or maybe even conveyance systems instead of mobile robots? The truth is, yes, you do need to consider everything, and you will most likely need to have some form of safeguarding, either hard barriers, safety products for scanning, but you could still have significantly less safeguarding than a traditional industrial robot or a conveyance system. So if you are tight on real estate, if you have an existing application, you want to shift from manual labor to automated labor, you could reduce how much you have to shift your existing space with these collaborative robots if you play your cards right and respect safety. So that is also to say, you can also make sure that if your application still requires a human touch, human intelligence, something that we can't automate yet, that you can still share those workspaces, but automate the menial tasks such as pushing carts or screw driving certain things and leave humans to do the more intensive work that requires our brain power, like detailed inspection, metallurgy, loading test samples into testing jigs for medical applications, things of that nature. And again, collaborative robots are designed for simplicity. A lot of the programming platforms for these are useful for redeployment. So if you are a small to medium end user or customer and you're growing, this might be a good step to have an affordable option to invest in for automation now that you can easily repurpose and reconfigure as your production area grows. The third misconception, safe operation is slow operation. If I have to use a collaborative robot and I have to use safety scanners, and if I have to shift to slow speeds, then that's just going to slow down my production, and I'm better off with 5 people working around the clock doing this, or an industrial robot instead of using a collaborative robot. That's not necessarily true. And if you play your cards right, you can actually increase your overall operating efficiency. So all these collaborative robots, the cobots and the AMRs, have different modes they can switch between. So for example, there might be a demo out there where a cobot hooked up to a safety scanner based on the proximity of people around it can either go from a higher automatic full speed mode to a slower mode to a full stop based on the proximity of people. And you can configure that based on the stopping times you need, the type of application you're doing. Similar for AMRs, you can have zones in your workspace where the robot slows down if it's a high traffic area, or even no fly zone so it doesn't block a certain area that people need to go through without worrying about AMRs. So yes, you will see slower speeds when you are sharing workspaces, or even see a stop in the robot while those people are in there. But if you configure your safety correctly, where you maximize the speeds and times during which people are not in the area, you can make sure that those slow interactions only happen when people are in proximity to the robot, and you maximize your cycle times when they're away. Of course, this also requires you to bring awareness to your workforce to say, hey, don't just hover around the robot, respect the safety around the robot. Don't film a TikTok of you jumping in front of a mobile robot to show that it stops. All of that. You have to educate your workforce. But this can be a vehicle for you to save on real estate, save on safety products, and still maintain high cycle times, assuming you've done your homework. And in terms of safeguarding, there's a lot of flavors you can do, and the correct answer is going to be wholly dependent on your workspace. Of course, we have light curtains, two-hand control switches to make sure an operator's hands are out of the way of a robot's working area, safety laser scanners to scan a wide distance, and even distance between a person and the robot to have multiple safety zones. Physical barriers are an obvious choice. And then other items like safety logic devices and monitoring relays if you want to connect to wider systems. Risk assessments. So this is something I see many customers and end users gloss over. In order to comply with many of the standards and regulations tied with robot safety, a risk assessment is always required. Now, it goes into much more detail about this. I could do a whole day seminar on risk assessments, but from a mile-high overview, there's 4 primary steps. There's preparation. You have to identify who is going to do your risk assessment. Sometimes a robot provider can provide that for you, sometimes your system integrator, maybe even a third party. But knowing who to rely on is going to be your first step. Secondly, you want to provide as much information as possible about the workspace, the application, the robot model. That will enable your assessor to hit the ground running. Task identification. You want to make sure that you identify the robot and the shared workspaces. Have that mapped out. You want to make sure that you have a plan in place, once again, to accelerate the risk assessment process, and make sure you identify who or what can enter the space. Is there going to be a forklift that comes in and drops a pallet off in proximity to your collaborative robot? Is there a high traffic pathway for people to walk through that crosses your AMR path? That also not only helps you design around that, but also know who you need to give awareness to about how to behave around these bots. Third is hazard identification. What on this robot actually poses a risk? So once again, is it the tooling when it's in motion, a conveyor topper that can cause uh, finger damage? Okay, I had to screw up at one point. There it was. Uh, crush hazards. There we go. Anything like that that could potentially pose a threat. You want to identify the risks so you know how you can actually mitigate them. And then that leads us into our 4th step, risk reduction. You identify where things can go pear-shaped, and you're doing your best to do risk reduction. Now, in many cases, you won't be able to completely eliminate risk, but you can at least mitigate it as much as possible and have a response when things go bad. Once again, these are required for certain standards. It's something that when you are considering purchasing a robot, you want to be prepared to address this. So that all being said, I do have 3 scenarios I want to go through with how you would possibly install a collaborative robot in your space while still getting that gold star sticker on safety. Just some terminology before we go on. I did copy this graphic here where blue spaces indicate a robot only workspace. Gray areas indicate where operators and humans are only in, and the yellow is where shared workspaces are. So where people and robots can occasionally share the same space. So we're going to start with a simple case first, desktop screw driving. So let's assume you have a collaborative robot mounted near a desk. You have an operator that loads a part onto a jig. The cobot is receiving screws from a screw dispenser, screwing them into the part that you loaded on the jig, and then the operator takes that off and does some more post-processing work. This is a fairly common application we see for cobots, where you just want to automate the menial tasks while the person wants to do the tasks that require that human level of intelligence. So the main risk here, assuming that that cobot could never reach the height of that operator's neck or face, is going to be a crushing hazard. So what happens if that person has their hand near the jig while that robot's performing that screw driving? There's a few options we have here. You could have that in an enclosure with an open top with safety gates. So if the safety gates detect that the person's hand or arm is still in the proximity, it'll stop operation until that person withdraws their arm. Or you could have these two-handed safety switches like here, where the operator has to put their hands on two buttons to make sure that there's no fingers near the pinch points. Obviously, one's more efficient than the other if you're just out of the position rather than you have your operator's hands tied. So there's various solutions to this, but there always might be one that is the most efficient. Let's go into a harder one. AMRs and exits. So this could be any AMR application. But what happens when you have an emergency in your plant and you have either AMRs still moving, blocking exits, or they respond to an alarm in your system and they block an exit during a fire? Not an ideal scenario, especially with the sizes we're seeing AMRs today, where they can be absolutely huge with heavy payloads that you can't just simply push out of the way. So in this scenario, we have an exit up here, a shared pathway used by both AMRs and operators, and obviously a clear path between the operator and the exit, assuming that there's no AMR in the way. So you could have it where you have an alarm system in your facility communicating with the PLC that communicates to your fleet. So you can have it where an alarm system will trigger some sort of desired behavior in your AMRs. Now, if you have to have a path for your AMR that could potentially block an exit, you'll need to consider something like having a routine that runs when that alarm trigger is triggered to send the fleet away from these exits, to move to a position where it knows that it can't be a blocking hazard and entrap people. Alternatively, you can even map out no-fly zones for your robots. These are screen shares of Mobile Planner. All of these different colored boxes are different sectors. So for example, this purple sector here indicates that the AMRs can only move in one direction. Or we have areas like these orange spots where these are no-fly zones. The AMRs cannot enter there even if they have to reposition and reroute. So you can proactively identify during the risk assessment process, hey, we don't want these AMRs here in any scenario in case of an emergency. So they might have to take a longer route, but you are at least covering yourself for those potential disastrous situations. So that was a really good example of knowing your workspace before you do that deep dive. Case 3, palletizing. I know that this is a very, very, very popular application with collaborative robots and one where I see the most safety concerns. So I've been harping on this a few times during the talk here, but cobots are not allowed to come into contact while in motion with the person's head or neck. There are certain force limiting conditions where a robot, a collaborative robot specifically like this, can come into contact with your body, your arm, your legs, but they have to be at certain limited forces and limited speeds. But head and neck regions are completely out of the question. The robot has to be fully stopped. So what happens when you have a large stack geometry you have to load onto a pallet? Well, you can't just have it in the open air, unfortunately. In this scenario, we have a conveyor taking boxes loaded on by the cobot from a pallet. You ideally have an operator sharing an area around here so that they can load the pallets of boxes on here for the cobot to take and depallet. So an open air solution is not ideal. Additionally, like I said before, payloads can turn into projectiles. If you want to have this booking at 100% speed and you have, let's say, a 20 kilogram payload, let's say you have a pneumatic gripper and your compressor in your facility dies out, then your cobot working at 100% speed just turned that into a boulder. It effectively became a trebuchet, and God help anyone in that area. So it's not just about the workspace or the application, it's also about the payloads as well. So we have to respect physics when it comes to robotic safety, not only in terms of, hey, if this cobot's moving at 100% speed and someone just starts bum rushing at the robot, you have to respect that the robot still needs time to actually stop, which will determine what sort of distances your safety devices are able to actually detect the presence of someone or something and react accordingly. So there's a lot of variables here, which makes palletizing a very interesting application. A potential solution is actually to put up safeguarding. So yes, you will have to have hard barriers in this scenario where you also have two sets of safety gates here. So in this case, we set up two pallets side by side on the robot. So one can be loaded by a forklift or someone with a push cart while the cobot is working on the second pallet here. So this safeguarding helps prevent those payloads from becoming projectiles. The robot can either stop or reduce speed when someone or something is in proximity to the safety gates, and then resume operation when everyone's out. So we're starting to see a scenario where it may be more practical to have a traditional industrial robot. I'm not trying to tell you that collaborative robots can solve everything. There are scenarios where, based on your target cycle times and your overall efficiency goals, you may want a industrial robot where you have to have extensive safeguarding. You may want conveyance systems instead of an AMR fleet that can adapt to a dynamic environment. And I think that's an honest conversation you have to have with yourself. Cobots are indeed sexy. They're on the front page of every single trade show advertisement. But don't ignore traditional robots when it comes to performance. And I'm not just saying that because Omron sells industrial robots as well. So it depends on the manufacturer. A lot of times, more traditional uh, industrial robots, these are all industrial robots, but I'm going to refer to SCARAs, parallel robots, and articulated arms that are not collaborative as traditional. It really depends on the manufacturer. Oftentimes, the more traditional robots are more expensive because you're getting more performance out of them. Because they're expected to have safeguarding, they can simply go faster, move higher payloads, things of that nature. And that also relates to the cost. But once again, there are some companies coming out with very affordable industrial arms. Uh, it it's kind of an it depends answer that I don't like to give, but I have seen collaborative robots be on the cheaper end by merit of them not being able to go as fast or lift those higher payloads. And I think we're starting to see the upper limit of what those can do. Like I said, there's only so far you can reach and only so much you can pick up before you violate what it is to be collaborative. We're currently sitting around 30, 35 kilograms as the market upper level. But if you're telling me that you can have a 5 meter long arm pick up 100 kilograms, how do you make that collaborative? How do you share a workspace with anyone under that condition? So
By that, you just mean that it's it hits you, it stops, right? It's essentially
yeah, but at that payload and at oh yeah, you said at that point, if it would strike someone, it would stop.
well to be collaborative. That's
Right.
is that they have protections that when they impact a person, they won't go through them. They'll stop. They sense that. And what you're saying is by going to too large of an envelope or too much mass, it doesn't make any sense. By the time it can't physically stop that quickly, it's going to do damage.
Correct. Or if you were to set proper safety variables and speed and force limiting, you might have a diameter that goes from here to the parking lot where no human can safely enter and the robot has to fully stop. At that point, it doesn't become practical with the current standards we have.
But collaborative robots are designed
If you're
prevent or
getting
minimize.
minimize, that's an area that can't withstand much pressure. So if you're having a collaborative robot or a traditional robot contacting somebody at a very sensitive part of the body, it's going to cause damage.
Yeah, and collaborative robots oftentimes will stop if they sense some sort of resistance, but that is still a worst case scenario. We want to prevent any scenario where the robot comes into contact with anyone, even if it is one of the quote unquote safer regions at a slower speed. Yeah. So that actually is a pretty decent segue into my last slide here. So buyer's guide. What to ask or what to ask your customers and end users before they dive into the world of cobots and AMRs. First one off, is my application actually collaborative? Once again, if you have ice picks or 300-degree tempered glass straight from the oven, that's a non-starter. And I would retool people towards looking at safer traditional industrial systems where you still need that safeguarding and you might even get a little bit higher production efficiency. Two, what safety functions are available with this robot? Obviously, you have your standard suite of e-stops, but you also have to consider safety scanners. Can those safety scanners be configured based on the payload? So with AMRs, oftentimes you'll have larger toppers or payloads that overhang and extend beyond the robot's footprint. How many safety scanners are on this robot? Can I configure them to not get false readings on the payload and just stop? Can I attach more safety scanners to it? What safety products are compatible with this robot and what safety IO is available on the robot? Once again, can I add more safety scanners if I have a niche application or something like a mobile manipulator where you have a collaborative robot on top of a AMR? What can I do to add to this solution to ensure I'm still complying with safety standards and regulations? And four, who can perform a risk assessment for my application? Once again, is that your robotics provider? Is that your partner or SI? Is that a third party you can hire out? Having all of these answers up front can help you with your buying decisions and even your fundamental design of your robotic solution instead of realizing this halfway in and having to redesign the whole kit and caboodle. And that is everything I had. I think we have about 15 minutes for Q&A if anyone had questions. Not all at once.
What is the relative cost of some of the products that you showed in the presentation?
That's another it depends answer. Of course, that's going to be based on primarily payload and performance. So most cobot arms are priced by their payload and reach. I would say market prices for collaborative robots, they can be as low as $5,000 up to, I would say, $75,000 USD. Sometimes the cheaper ones have limited functionality, maybe not as graceful programming instances, or are just otherwise made of cheap components. So you definitely don't want to overpay or underpay for a collaborative robot. So I would definitely refer to that buyer's guide I shared at the end to make that selection. Similar for AMRs, there are a lot of autonomous mobile robots out there. Bear Robotics has robots that are for a restaurant. So I've never seen those robots in an industrial application. I've seen them carry sushi to my table a bunch of times, but even though they're on the cheaper end, is that going to suit your industrial environment? So you're talking about Payless shoes or that was a bad analogy because I don't know any high-end shoe providers, but do you want a Rolls Royce or a Lemon? I think you had a question.
Potentially a cobot working with a collaborative robot in an area, potentially an AMR with a just standard industrial robot.
We do actually. So that would require. Oh, yeah. The question was, would you ever see applications where a collaborative robot be it an AMR or a cobot, interacts with the traditional industrial robots that would require the additional safeguarding. And we actually do. There may be parts upstream of a process where you need either the precision, repeatability, speed, and payload of these traditional robots. But for downstream in the application for, let's say, palletizing parts in a container or heavy boxes onto a pallet, that's something more suitable for a collaborative robot. So you can mix and match those solutions. The big concern here is making sure you have the safeguarding around that industrial robot, and then the proper amount of safeguarding in between where that handoff occurs and loads onto the AMR. A common example would be a traditional articulated arm that you would need safeguarding for, putting parts on a conveyor that would then load onto a conveyor topper for an AMR. So you could have a safety laser gate within that conveyor tunnel to make sure that no one's reaching in to there, potentially getting in the industrial robots workspace. You would still need some safeguarding around where that conveyor ends and transfers to that conveyor topper, because that's still a pinch point, that's still a crushing point if someone happens to put their hand on top of that AMR conveyor. But there are ways to hand off, and we do see that in the field.
They fail and they will result in a safe outcome. So that's why it's something that taking into account is the potential for failure of partners. So if you think of something like a mobile robot driving